Welcome to the Unit 2A reteach. Please follow along with your paper that you received along with our reteaching materials. The first topic in Unit 2 is going to be Venn diagrams. So here's a little snippet of the question you should have on your paper. So a survey was done. A student took a survey at their high school to determine if one gender group is more likely to own an Apple product than the other. Some information from the survey is as follows. A total of 226 students were surveyed. Of those surveyed, 95 were male. Of those surveyed, 112 owned an Apple product. Of those who owned an Apple product, 60 were female. So what we need to do is analyze this information to decide what should go in our two circles. So the first thing we should probably do is go ahead and draw a couple of circles on our paper. So here is one circle, and here's the other one. And then we have to decide what goes in those two circles. So in a Venn diagram, a circle represents an either-or kind of situation. Either you fit the description and you're in the circle, or you are the opposite of whatever's in the circle and you're outside of it. So let's say this circle over here on the left, let's label that the female circle. So if you are a female in this study, you will be in one of the sections. You will be in section 1 or section 2. That is all the numbers for females in this survey. If you are a male and you are taking this survey, you will be out here in either section 3 or section 4, which really isn't even in the diagram. It's kind of just outside of the two circles. Alright, so the other either-or relationship, we need to label the other circle with that information. So either you have an Apple product or you don't have an Apple product. So if you're in the circle in section 2 or 3, you have an Apple product. If you're in section 1 or 4, you're outside of that circle and you don't have an Apple product. So start filling in information. So we know that people who own an Apple product, 60 of those are female. So that fits in section 2 because it fits both of those criteria. Right, of those surveys, 112 owned an Apple product. So this Apple sections 2 and 3 have to add up to be 112. So I know that in section 3 I could do 112 minus the 60 that I already had, and I find out that there are 72 males that own Apple products. Alright, so then of those surveyed, 95 were male. Well, that would be, sections 3 and 4 would be where the males go. So in this circumstance, we know that there were 95 males. We know that 72 of them owned an Apple product. So in section 4, outside of the two circles, we should have 23 people who fit in that section. So we've got one more piece to go, and that will be the female circle. So right now we should probably figure out how many females there are. So if you take the total number of students, 226, and you subtract all of the male students, and then you'll also subtract the 60 females who we know own Apple products, we should get our answer for that section. 226 minus 95 minus 60 leaves us with 71 people who are female who do not own an Apple product. So that's what is in section number 1. Now what we want to do is use this diagram in order to answer some of the questions that follow. Alright, the next question after drawing the Venn diagram is, what is the probability that a randomly selected survey participant was male? So they haven't given us any specifications to cut down or change the total number, so we're going to use 226 as our denominator because that's all the people in the survey. And then we just want the male ones. Well, our data says that there were 95 of those that were male, so here's our fraction. 95 over 226. Now we can leave the answer like that, or we could do some division, and we would find out that that would round off to about 0.42. If we needed our answer as a percent, we could multiply by 100, and we can move the decimal place a couple of places over. So multiplying by 100, that gives us 42% would be the percent of participants that are male in our study. Right, the next question is, what is the probability that a randomly selected survey participant was female? So again, our total is 226. That is not changing, but the numerator will change. So if you look at the female circle, you'll notice that there are numbers 71 and 60. So what we want to do is add those two together. That tells us that there are 131 females in the survey. Do a little bit of division. If you do 131 divided by 226, you'll find out that that is about 0.579. Now that might round up. You could say 0.58 if you wanted to. I'm just going to leave it there and truncate my numbers. That means chop off everything after the third decimal. So 57.9% would be my answer for how many, the percentage of the females who are in the study. Our next question is, what is the probability that a randomly selected survey participant was male and owned an Apple product? So for this particular one, we want to look at the males, which would either be our 72 or our 23. And since we want them to be male and own an Apple product, 72 is going to be the number we're looking for. So we'll go back to our fraction. The denominator is still 226. Let's go ahead and put 72 on top of that and do a little bit of division. When you divide that out, you get 0.318 if you truncate the number at 3 decimals. So you could say that about 31.8% of our survey participants are male and also own an Apple product. Moving right along, our next question, what is the probability that a randomly selected survey participant was either male or owned an Apple product? So again, we are still keeping with the same denominator, 226, but this time we need to count up all the males. We know that there are 95 males in the survey, but not only are they looking for males, they're also looking for anybody else who might have owned an Apple product that isn't a male. So we're going to take all the males, all the females that own an Apple product, that comes from section number 2 there, the 60, and add those two numbers together. So whenever you do 95 plus 60, you get 155. So 155 out of 226, that's the fraction we're working with. Do a little bit of a division, 155 divided by 226, and you will get something like 0.685. So again, if we change this to a percent, move the decimal over or multiply by 100, whichever way works for you, you've got 68.5% of the people in this survey were either male or they had an Apple product. For these last two examples, F and G, we're going to change things up a little bit. In the question, you'll notice the words given that. If you ever see those two little words, given that, it means your denominator is about to change. So, question F, what is the probability that a randomly selected survey participant owns an Apple product given that the participant is male? So, it says given that the participant is male, we want the denominator to be only the males in the study. Our question information says that there are 95 of those. So out of just the males, that leaves us with sections 3 and 4 because those are the male sections of our Venn diagram. We want males that own an Apple product. So that's going to be from section 3. That is 72. So we do a little bit of division. 72 divided by 95. And we get our decimal 0.757, which is the same as 75.7% as the answer to this question. The last question on the page, what is the probability that a randomly selected survey participant owns an Apple product given that the participant is female? So this time, our given that is females. So what we want to do is go ahead and change our denominator. That's going to be 131 because there are 131 females. So I'm going to look in the female circle. That is sections 1 or 2. Females who have Apple products, that's right there in the center. That would be 60. So whenever you do a little calculation, 60 divided by 131, you end up with 0.458. So 0.458, change that to a percent, you could say that 45.8% of our female participants have Apple products. And that concludes the Venn diagram section of this lesson. The next piece of this lesson is about using tree diagrams. So we have a situation where Mr. Silva surprises his students with a probability challenge. He puts 3 cubes in each of 3 paper bags, a red cube, a white cube, and a blue cube. He divides a class into 4 groups of students and tells them that each group will draw 1 cube from each bag. Draw a tree diagram to show the sample space. So we've got our bags, we've got bag 1, bag 2, and bag 3, and now we need to draw a tree diagram that shows this. So the first thing that could happen is we draw a cube from bag number 1, so you could get either the blue cube, or you could get the red cube, or you could get a white cube. This happens again, you draw a second cube, so again you are left with the options of blue, or red, or white. Same thing here. Just continue on until we have all of our options listed. And then we move on to bag number 3. So this one, things may get a little bit crowded, but you go ahead and you fill it in, blue, red, and white, all the way down the page. So you can play with those little lines until everything kind of fits on there. The most important thing about this diagram, you'll notice there are no numbers on it anywhere because everything has an equal probability of happening. There's not like extra cubes anywhere. We're not looking at percents of the time that something happens. We're just saying, hey, you got 3 cubes in a bag and you get to pick one, and then you get to pick another one, and then you get to pick another one. Alright, so what we want to do, the first question was how many different outcomes are there? We can go through and we can count all the little branches. So you can just start at the top and count 1, 2, 3, 4, 5 all the way down. You'll find that there are 27 of those branches. If you need to take a moment and pause this so you can count, do that. The other thing you could do, we know that there are 3 cubes in each of 3 bags. We can multiply 3 cubes times 3 cubes times 3 cubes, and surprise, that turns out to be 27. So there's a couple different ways to do that, through counting or through multiplication. So the first question that we need to calculate says the group ends up with a red cube, a white cube, and a blue cube. So let's go through and look at the diagram and see where this happens. We're not going to use the top set of branches because it goes from blue to blue, and then that would give us 2 of the same color cubes, so that wouldn't be very good. But we could go from blue to red to white right here. We could go from blue to white to red. We could go from red to blue to white. We can't do the center strip with this other red because it'd give us too many reds. You could go red, white, and blue. You could go white, blue, and red. You could go white, red, and blue, but then this bottom one, you can't do white, white, because then it would be all messed up. So count your little branches, 1, 2, 3, 4, 5, 6. There are 6 out of 27 different ways that you can get one of each color. So you could go ahead and divide that. 6 divided by 27, that's going to be 0.222. Or you could say 22.2%. If counting doesn't make you particularly happy, consider the little bags again. Here they are. You've got the blue, white, and red in each bag. If you're trying to get one of each, the first bag, it doesn't matter which one you get. 3 of the 3 cubes are acceptable for this experiment. The second bag, once you've picked something like blue, then only 2 out of your 3 cubes are good. And then for the last bag, once you pick like a blue and a white, the only thing left is for a red to happen. So you could go ahead and multiply 3/3 times 2/3 times 1/3. That gives you 6 out of 27, which is exactly the same thing we got whenever we counted branches. For the next question, what is the probability a group ends up with at least 2 red cubes? You could go through here and you could find all the different places where you have 2 reds. That's not going to happen on our top branch, but we could start here with the second one, blue, red, red. Not going to happen on this third little branch right here with blue and white, but you could go to RBR. You could have a red, blue, and then a red. You could have a red, red, and blue, red, 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 white. Or you could go red, white, and red. On the white branch, the only way for this to happen is to have white, red, red. So then we can count up what we've got. We've got 1, 2, 3, 4, 5, 6, 7 different ones. So your probability in this case is 7 out of 27 different options. So go ahead and do a little division. 7 divided by 27. That looks like you're going to end up with 20.259 or 25.9%. Alright, the next example, you want to know if the second cube selected is white. So there are only a few places where that can happen. And I've highlighted 3 of those. So off of that, you've got 3 little ways that can happen at the top section, 3 little ways in the middle, and 3 ways at the bottom. So count those up. That's going to give you 9 possibilities out of 27. So you do a little bit of division. That should be 1/3. So that's either 0.333, or you could say 33.3% is your chance of getting a white cube second. You could also come over and consider the little bags with cubes in each. The first bag, we really don't care what we want. 3 out of 3 of those are acceptable, but you want the second one to be white, and you want the third one, doesn't really matter what color that is. If you multiply across, 3 times 1 times 3 is 9. 3 times 3 times 3 is 27. So again, you've got 9 over 27, which is the same 33.3% that we had whenever we counted branches. So this last question, letter E, it says a group ends up with 2 cubes of the same color. So you could go through and count all of those. It doesn't say that you can have 3 cubes of the same color, so we're going to go with just 2. So if you look at this, you've got blue, blue, white. And blue, blue, red. You could have blue, red, blue. You could have blue, white, blue. You could have red, blue, red, 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 blue, red, red, white, red, white, red, white, blue, white, white, red, white, 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 blue, and white, white, red. So when we go through and we count branches, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I've counted correctly, looks like there are 12 different ways this is going to happen. So then we're just going to write that, 12 out of 27. And we can move on, do a little bit of division, and you end up with 0.444, or 44.4%. With that being said, this concludes our Unit 2A reteaching review. So we hope you have a nice day, and go take your retest.